Hello students, let us start our discussion about different methods to solve the numerical problems. Likewise, the free body diagram. If we well know about the free body diagram forming for any object experiencing many forces upon itself, then we can solve different types of numerical problems in easy way. So for this we have to know some basic concepts. Likewise, suppose that what will be the amount of the acceleration acting on any object placed on any smooth surface if some external force is moving that object. Suppose that acceleration in a body on horizontal smooth surface, horizontal smooth surface. Okay, so suppose that we have a plane and this is a smooth plane. We can consider it as a frictionless plane. Then if we consider about an object of mass m placed over on this plane, then what will be the amount of the weight of this object? This will be equal to mg, and this mg is always acting vertically downward. So if this is just placed over the surface, then there is a normal reaction acting by the surface of this plane on the body. So the reaction will always be just normal to the surface of this body plane. So this will acting always vertically upward. Suppose there is a force which will tend to move this object, and after applying that force, object is start its motion and continuously object increases its velocity, so that we can say that there is a acceleration introduced in the object. So if we consider there is a force acting in that direction which makes some angle theta with the direction of horizontal, then if anybody applies some force F on this object to pull this over the surface, then suppose that if object will move towards F with an acceleration A, then what will happen? How can we equate different types of force equations to balancing each other? For this we can easily calculate what will be the acceleration acting in this body when this force is applied. We can easily calculate if we resolve this F in its two component, one along horizontal and other along vertical. So we can easily find out what will be the value of the vertical component. This will be equal to F sine theta, and this horizontal component will be equal to F of cos theta. Okay, so if there is an acceleration produced in this body is A, then the force by which the object is pulling in horizontal direction, that will be equal to ma. This is the force. So this ma is equal to the F cos theta. But as we know that when there is a force acting on this object, then if we write the balancing force in vertical direction and in downward, so we get the total vertical force acting on this object is R plus F sine theta, R plus F sine theta, and this will balances by a particular force, that is mg. Okay, so similarly, if we want to calculate what will be the amount of the force acting on in horizontal direction, then the force by which this block of object is pulling, that is F cos theta, and by applying this force the object is experiencing some acceleration a, so the force experiencing by the block of mass m will be equal to ma. So there are two different formula in this case. From here we can easily calculate what will be the acceleration produced in this object. From second we get F cos theta divided by m. Okay, and here the surface is considered as very smooth, that is frictionless, so we can easily solve and find out the value for the acceleration produced in this object. If we put the value of F from first, that is mg minus r divided by sin theta, so we can easily get what will be the value of a in terms of r, m and g and theta. Okay, so this is a simple case. Now let us take our second condition. If this smooth surface is considered as an inclined plane, then what will happen? So let us start the discussion about acceleration in a body on a smooth inclined surface. Suppose that we have a surface, inclined surface, whose inclination is theta from the horizontal, and an object of mass m is placed over on this inclined surface. Then the weight of this object is acting vertically downward, and this will be represented by mg. Then the normal reaction acting on this object by this contact surface is normal to this surface, that is r. So if object is pulled in upward direction by a force F, and it is found that object is at rest initially, then if we resolve this mg in its two component along the normal to this contact surface and along parallel to this contact surface, so this normal to contact surface becomes mg of cos theta, and this becomes mg of sin of theta. So if we assume that the force acting on this block is such that the object is at rest position, so this force will balanced by this mg sin theta, and the normal reaction R will balanced by the component of mg, that is mg cos theta, R equal to mg cos theta. So from here we can easily calculate what will be the value of inclination, and what should be the value of inclination for a body of mass m on any frictionless surface for which it cannot move in downward direction if we apply some external force. So for an angle of theta, this becomes F equal to F by R is equal to sin of theta divided by cos of theta, that is tan of theta. So from here theta can be written as tan inverse F by R, and if this force balances the object moving downward, so if the acceleration produced in this object in this case is a, then this F can be written by ma. So from here we can write it as ma equal to mg sin of theta. So what will be the value of a? That acting along the inclined surface, because we know that g is always acting vertically downward, but the component of this g along the contact surface is g sin theta, which balances the acceleration acting in upward direction. Okay, so this a have a formula, that is g sin theta. Now let us assume a third case in which a system of object and plane will be accelerated in particular direction by an acceleration of b. Then what will happen? What will be the amount of the acceleration produced in that object? So let us say acceleration in a body is on a smooth inclined surface which experiencing horizontal acceleration b. Suppose that there is a inclined surface whose inclination is theta, and this total inclination plane will be experiencing a acceleration b towards this direction. Then if this total system of the plane is moving in this direction, and if we assume that there is a body of mass m placed over on this surface whose weight is mg, and where m is the mass of this body, then what will be the normal reaction acting on this body? This will be just equal to normal to the contact surface that is along this direction. Then we can resolve this mg into its two components, one along here and other along here. Because this one is theta, so this is also equal to theta. So this becomes what? This becomes mg cos theta, and this becomes mg sine of theta. Suppose that the body will tend to move in this direction by its own component. So if the acceleration acting in this body is a and the mass of this body is m, so a force experiencing by the body along this direction is ma. If you consider the body will move along this direction with its plane, then what will be happen? If there is an acceleration b acting on this surface, then the body will experience another force acting in this direction, and this force will be equal to m multiplied by the acceleration acting in this direction. Okay, this will be equal to mb, and this mb can also further resolve into two component, one along parallel to the contact surface area and other along the perpendicular to contact surface area. This becomes mb, because this one is the theta, so this is also equal to theta, so this becomes mb cos theta, and this one becomes mb sine of theta. Okay, so what will happen at here? As we are seeing that the total normal reaction component for force, that is R, is balanced by mg cos theta plus mb sin theta. So R is equal to mg cos theta plus mb sin theta, and from here we are seeing that the object is moving vertically along the contact surface plane by acceleration a. So the force acting in this direction is ma. So ma is the resultant force. This will be equal to the force by the object pulling towards this direction minus the force by is opposing the motion, that is mg sine of theta minus mb cos of theta. So from here we can easily get what will be the value of acceleration. This will be equal to, by cancelling m both sides, we get g of sine theta minus b of cos theta. So this is a simple formula for the acceleration produced in the body which is placed on a inclined surface, and the total plane and the body is pushing in this direction in which object is moving by itself. Okay, so this is a simple case, and we can use all these topics, all these type of methods to solve different types of numerical problems. So use FBD and solve different types of numerical problems. So by the way, theoretically our chapter laws of motion will finish. Tomorrow we will solve different numerical problems and then we will start our next chapter, work, energy and power. Okay, till now take care. Thank you.